Hi, welcome to Math 1400, Nunez Community College. This is section 1.2, which is the unit circle. As we know so far, we know that there are 6 trig functions. We have the sine of an angle, cosine, tangent. The inverses of them is the cosecant, the secant, and the cotangent of the angle theta. Now, if theta is an angle that's on the terminal side of theta, we have a point x comma y, which is on the terminal side of theta, and this is on the unit circle, meaning that the radius of the unit circle is 1, we would know that the sine of the angle theta is going to be nothing more than the y value of the ordered pair. The cosine is going to equate to the x value of the ordered pair. The tangent is going to be y over x. Cosecant, being its inverse, is this flipped, or the inverse of it, which is 1 over y. The secant will be 1 over x, and the cotangent will be x over y. Now, in the first example, it says find the value of the 6 trig functions, which these are the 6 trig functions, if the number on the terminal side of theta has an ordered pair of 3/5 and 4/5. Has the ordered pair of 3/5 for the x value and 4/5 for the y value. If this is the case, we would say that the sine of theta is equal to the y value, which the y value would be 4/5. The cosine of theta is the x value. The x value would be 3/5. And the tangent of theta is y over x, or 4/5 over 3/5. But this is a complex fraction, which you can't have, so we could take the bottom fraction, flip it, and multiply it, or know that since we have the same denominators, they can cancel out, giving us 4/3. The top number over the bottom number, 4/3. The cosecant of theta is the inverse, which is 5/4. The secant of theta is 5/3. And the cotangent of theta is 3/4. So this would be the 6 trig functions evaluated if this was our point on the terminal side of theta, and it's given to us. If it's not given to us, there are certain things that we need to be able to know. For instance, if this is a unit circle, we allow the radius to be 1, therefore knowing the ordered pairs of 4 different points on the coordinate plane. So we know the 4 points, which is going to be here. This ordered pair is going to be 1, 0. Because again, it's a unit circle, and our radius is 1. So the coordinate at this point would be 1, 0. This point here would be 0, 1. Back here would be -1, 0. And then this would be 0, -1. We also know these angles because of the unit circle section that we had. This is either 0 or 360 degrees. This is 0 or 2 pi, if we're talking about radians. Here we have 90 degrees or pi over 2. This would be pi or 180 degrees. And then we have 270 degrees or 3 pi over 2. Again, that's when we filled out the ordered pairs. That's when we filled out the unit circle, and we looked at what we had. So for this, if I decided to look at this, I could actually find the answer or the 6 trig functions of those angles all listed. So suppose instead of being given that ordered pair, I put in the angles, which is finding the 6 of, let's look at 90 degrees. So I have 90 degrees. Sorry about that, but my board is not dry yet. 90 degrees, cosine of 90, each one. I could say pi over 2 if I was doing it in radians, but I would look at it. I know that the sine we just got done saying was the y value. So I would look at the 90 degrees. Here's my ordered pair. The y value is 1. And indeed, the sine of 90 degrees is 1. The cosine of the 90 would be my x value. At 90 degrees, the ordered pair, the x value is 0. At the tangent, it's y over x or 1 over 0. The cosecant is the inverse or the flip, which is 1 over 1, 1. The secant is going to be this flipped, which is 1 over 0. And the cotangent is this flipped, which is 0 over 1, the inverse of that. Well, these 3 are fine. However, these fractions that we have simplifies or are written in different ways. 0 over 1 is 0, and 1 over 0 is undefined. Undefined. I always write it as 0 over 1, 1 over 0. If 0 is over the 1, then that is equal to 0. It starts with a 0. If 0 is under the 1, 0 is on the bottom, under starts with a U, so it's undefined. Remember, you must list it as undefined or 0. You cannot leave it as the fraction. So any of the 4 angles that we have, using these ordered pairs, we can find the 6 trig functions of that. So let's look at some others that we may have, and we're going to look at the corresponding ordered pairs that go along with that. All right. In another video, I'm going to show you how to achieve these ordered pairs, but what we have to know is that on the unit circle, we know that this is 0, 360, or 0, 2 pi. We know that that ordered pair is 1, 0. We know here again, 90 or pi over 2. We know this one is 0, 1. At 180 or pi, we know our ordered pair is -1, 0. And at 270 or 3 pi over 2, our ordered pair is 0, -1. But at 45 degrees, if I split it, this becomes 45 degrees, which is pi over 4. The ordered pair is square root of 2 over 2 and square root of 2 over 2. That's always the ordered pair for that. At the 30-degree angle, which is pi over 6 radians, the ordered pairs are square root of 3 over 2 for the x value and 1/2 for the y value. And at 60 degrees, which is pi over 3 radians, the ordered pair is going to be 1/2 square root of 3 over 2. 1/2 square root of 3 over 2. Now, these are the ordered pairs that you must be able to refer back to and remember. Because if we're trying to do the 6 trig functions of any of those, we would see that we use those ordered pairs in order to answer it. So suppose we were looking at the angle theta being 45 degrees, or pi over 4. So theta is pi over 4. We could find the 6 trig functions of that angle. So sine being the y, we come over here. The y value is square root of 2 over 2. So the sine of pi over 4 is square root of 2 over 2. Cosine being the x value, square root of 2 over 2. Tangent being y over x, square root of 2 over 2 over square root of 2 over 2, which is 1. Cosecant, if this is flipped, we come up with 2 over square root of 2. We cannot leave a radical in the denominator of a fraction, so we must multiply by what we want to get rid of, which is square root of 2. So we multiply by a sneaky form of 1, square root of 2 over 2. Square root of 2 over square root of 2. And we multiply across, that's 2 square root of 2. Square root of 2 times square root of 2 is 2. Square root of a number times the square root of the number is the number. Cancel these out, and square root of 2 would be our answer. The same thing happens here. It's the inverse of this, which comes up to be the same thing, square root of 2. And here, it's the same thing, square root of 2 over 2 over square root of 2 over 2, which is 1. So any of the angles that we know, we can find it by using the sine being the y, the cosine being the x, and so on and so on. But the thing is these ordered pairs, which is so important, occurs in all 4 of the quadrants. So if I did this, and this, here we would have 120 degrees. We would have 2 pi over 3 in the second quadrant, but the ordered pair would be the same as the 60. It would be 1/2 square root of 3 over 2. For now, leave it at that. Over here we would have 45, so that's 135, or 3 pi over 4. This ordered pair would be square root of 2 over 2, square root of 2 over 2. Exactly like we have here. And then this one over here would be what, 150, which would be what, 5 pi over 6. And that one would be the same thing, which is square root of 3 over 2 and 1/2. The same as here. Once we've done it though, and we put down what we have, we now have to realize that this is in quadrant 2. And in quadrant 2, certain things are negative. And in quadrant 2, the x values are negative. So I'm going to put this as negative 1/2 square root of 3 over 2. I'll put this as negative square root of 2 over 2, square root of 2 over 2. And here we'll have negative square root of 3 over 2, 1/2. So in the different quadrants, the different ordered pairs are negative. So here we would have what? 5 pi over 6. This is what? 7 pi over 6, or 210 degrees. And the ordered pair would be the same, square root of 3 over 2, 1/2. But in the third quadrant, both of them would be negative. This would be 5 pi over 4, or 225 degrees, square root of 2 over 2, square root of 2 over 2. Both of them are negative because it's in the third quadrant. Here we would have, what will we have here? This would be 240 degrees, which would be 5 pi over 3. Sorry, 4 pi over 3. And that would be the ordered pair, which would be 1/2 square root of 3 over 2. Both of them would be negative. This would be 5 pi over 3, 300 degrees. And this ordered pair would be 1/2 square root of 3 over 2. The y value would be negative, so we would put negative for the y. This would be 315, which would be 7 pi over 4. And then we would have what? Square root of 2 over 2, square root of 2 over 2. The y value would be negative. And then 330 degrees, which would be 11 pi over 6. And that would be square root of 3 over 2 and 1/2. And the negative would be at the y. That would be the unit circle and all of the corresponding ordered pairs that go along with the angles that we're mentioning. But once we have that, we could do all 6 trig functions of any of the angles on the unit circle. One of the examples they'd like us to do is they want to evaluate specific things. Like, let's look at 2 pi over 3. So let's make theta 2 pi over 3. Just as an example of being able to do the 6 trig functions. Okay, so theta is 2 pi over 3. So we find 2 pi over 3. We know that at 2 pi over 3, our ordered pair is negative 1/2 and 3/2. Sine is the y value, so therefore it's square root of 3 over 2. Cosine is the x value, negative 1/2. Tangent is going to be the y over the x, so that's going to be what? Negative square root of 3 over 1, which is negative square root of 3. The cosecant is going to be 2 over square root of 3, which we can't have a radical at the bottom. So we multiply by square root of 3 over square root of 3, and it's 2 square root of 3 over 3. Negative 2, and finally negative 1 over the square root of 3, which we can't have. So that's going to be negative square root of 3 over 3. But any of the angles on the unit circle itself, we can find any of the 6 trig functions. Any of the 6 trig functions. And finally, it says use a calculator to find the trig functions and round to 4 decimal places. Round to 4 decimal places. Guess I'll come over here and do it. I want to find the sine of 30 degrees. The sine of 30 degrees. We have to make sure that our calculator is in the right mode. This is degrees, so we're going to be in degrees mode. We're going to hit sine, we're going to hit 30 degrees, and it's going to should give us a decimal. If it doesn't, we have to look and find out the little button that is right above our enter button on the calculator, and you should be able to hit that and it will transfer over to a decimal. This is going to be 0.5. And it's 4 decimal places we're bringing it to, so 0.5000. Suppose I'm looking at the tangent of pi over 8. In this case, the tangent of pi over 8 is a radian, so we must switch it to radian mode. Once we do that, we hit tangent, hit the n over d button, pi over 8, and again, we should come up with 0.4142. But 4 decimal places is what they're asking us to bring it out to. And finally, suppose we have the secant of 2.3. Notice it says 2.3 and not 2.3 degrees, which means 2.3 is in radian measures. Now, what do we know first? There is no secant button on the calculator. So what we're going to have to do is we're going to have to find the inverse, which is 1 over the cosine of 2.3. So the cosine of 2.3 comes up to be 0.6627. 0.6627. We're going to hit the 1 over x button. And that will bring this to negative 1.5009. Negative 1.5009. Again, this is, or has been, the unit circle. Once we know the ordered pairs, which you must try to memorize the first quadrant, know that the other quadrants flip over from that with the same ordered pairs, just the negatives being whatever value, x's or y's, are negative in that quadrant. And once you do that, you can do the 6 trig functions of any of the angles that we have messed with so far. Okay, thank you very much. This has been section 1.2, the unit circle. I'll catch you at the next one.